Hi, I'm Holly Cummins, and I want to talk about some of the ways microservices can go wrong. I work for IBM, and these are all based on my experiences as a consultant with the IBM garage. These are all problems that I see in the field over and over again. And the first problem that I see is sometimes that we don't even know what the problem is. We feel we should be doing microservices, but we haven't really spent enough time trying to define why are we doing microservices? What problem are we trying to solve? What's hurting us now? What's going to be better after we've done microservices? And I think this is quite a natural human tendency, and especially for us as techies. We want to jump to the solution. We want to play with the new shiny, and sometimes the work to figure out what problem are we trying to solve, it's actually much less fun than solutioning. And I think with containers, because containers are they're almost a magical technology. They're so lightweight, they're so portable, they make so many things so much better. We say just because, I've got these containers, it would be a waste of the container capability to run my application in just one container. I should run it in as many containers as I can. But actually, not having enough containers is not a valid problem. Another problem that we see is CV-driven development. We look at our CV and there's a big blank spot where it should say microservices, and we say, I can fix this by re-architecting my company's stack. And it's like, well, that's a solution. That's not really a problem. And you may say, actually, no, that's just too cynical, Holly. Surely no one would actually make architectural decisions based on their CV, right? Turns out the evidence is that they would. Red Hat recently did a survey, and they looked at the main drivers for container-based development, and the number one driver was career progression, which is basically CV-driven development. But I think the main thing that really drives microservices adoption at the moment is that they're almost a new orthodoxy. Even if we're not taking part in the Great Resignation, and even if we're not looking for a new job, we look around and everyone else is doing microservices, and we say, well, if they're doing microservices and they're doing microservices, what's wrong with me if I'm not doing microservices? So it becomes this sort of fashion thing. And really, a lot of us have succumbed to microservices envy, which is, we feel we should be doing them. And one of our consultants has a sort of a rule that when he talks to a client, if they just say Netflix, which does happen a lot, he thinks, I think we're in trouble here. I don't think you're doing this for the right reason. But if they have a conversation that's a bit deeper and they talk about things like coupling and cohesion, then he thinks, okay, we're in the right space. But ultimately, we can't start our conversation by saying, I need to move to a microservices architecture, because microservices, they're not a goal, or at least, well, they are a goal, but they shouldn't be a goal. Microservices are the means to achieve that goal of business agility or whatever it is we're trying to achieve. And to be honest, they're not even the only means, they're a means. And one of the challenges that we see is that microservices on their own often help us, get to what we're actually trying to do. I love this quote, do you have microservices or do you have a monolith spread over hundreds of Git repos, which unfortunately is what we often see. And at that point, what we have is a distributed monolith. A distributed monolith is a really bad thing. It's hard to reason about, and it's actually really prone to errors, because with a conventional monolith where it's all running in a single process, you get things like compile time checking when you're developing, because your IDE can say, oh no, that method name has changed. And because you're always in the same process, you get guaranteed function execution. You don't have to worry about whether discovery and then whether the thing that you're trying to call actually exists. And so when we take those away, but leave the coupling, what we end up with is cloud native spaghetti. So I was called in to a project, and it was a troubled project. And pretty much when I landed, the first thing they said to me was, every time we change one microservice, another one breaks. And if you've been paying, any attention to the sort of the dream of microservices, the promise of microservices, it's that exactly the opposite is supposed to happen. They're supposed to be independent of each other. They're supposed to be decoupled. But decoupling doesn't happen for free if you distribute your system. Just because they both start with D, they're not the same thing. And it is very, very possible to have a highly distributed system with all of the pain that comes from being distributed, while still being completely entangled and coupled. And this was what had happened in this case. So when I looked into the code, I kind of, I was just doing an explore, and I kept seeing the same code over and over again in each repo. And I thought, this is kind of strange. And the object model in this case was pretty elaborate. There was about 20 classes, and some of them had 70 fields. So it was this really sort of complex schema. And each microservice had to basically duplicate that schema in its code. And because they didn't want a coupling to a common object library, which kind of makes sense, instead they copy and pasted the code. But of course that doesn't eliminate the coupling. If a field name changes, it still breaks everybody. You just don't get that warning. And this comes back to some of the ideas about domain-driven design that we really need to be thinking about when we're doing microservices. Because the goal, the ideal, is that you have a whole bunch of microservices, and each microservice maps really neatly to a domain. And this allows the interfaces to your microservices to be really small. But what happens in the bad case, and I think what happens if we're not really, really careful, is that we fragment quite small, perhaps along technical boundaries rather than domain boundaries, and then we end up in that spaghetti case. And the errors that we see from this can be quite serious and quite difficult to catch as well. This is the Mars Climate Explorer. Way before the most recent, very successful Mars mission, NASA did a mission where it was just going to go and it was just going to orbit round Mars. Sadly, it did not orbit round Mars. Instead, it went, crashed into Mars, and that was the end of the Mars Climate Explorer. So when they did the post-mortem, which really was a post-mortem in this case, at least for the ship, what they found was that there was 2 control systems. And most of the time, the control was done by a control system on the Explorer itself. And then every now and then, there'd be course corrections and supervision from a control system on Earth. So we have, a very distributed system. It couldn't have been more distributed. Part of it was in space. And, very sort of what seems to be quite modular. But of course, the domain is actually quite similar between these 2 systems. And turns out the root of the problem was they hadn't been quite clear enough in their communication about what the interface looked like. And so it was passing numbers back and forth. But the part in space used metric units. The part on Earth used imperial units, and so disaster occurred. And I think we can safely say in this case, the system was very distributed, and being distributed did not help. So there is a workaround here. There is a thing that we can do that we should all be doing, which is use consumer-driven contract testing. When we have this kind of system where the IDE isn't helping us out, we need to contract test our integrations. And this is really important because integration testing, we're going to do some of the time, but the whole point of microservices is that we shouldn't be having to do expensive integration tests with the whole system all of the time, or else we're not decoupled. But mocks on their own have a problem. And the problem with mocks is that we have a conversation at the beginning about what our interface looks like. And we come to an agreement. And then we go away and we try and write a mock that looks like our understanding of what they said their code looked like. In the ideal case, we get it right. But the problem is we bake our assumptions into the mock because we write the mock and we're maybe not the best person to know what the other code looks like because it's not our code. And we're certainly not the best person to know what the other code does. So in the happy case, we get it right. So our tests all pass, everything is good. Unfortunately, that's not always what happens. Sometimes their actual implementation ends up being different than what we understood, either because they changed their mind or because we made an assumption that was incorrect. And so in this case, the tests will still pass, but when we actually try it out, it's going to fail. So the solution is to not rely just on mocks that we write that are never validated or never even looked at by the other side. Instead, what we want to do is we want to have a consumer-driven contract test as an intermediate. So we have our code, we have their code, and we have a contract test. And the beauty of a contract test, why it's different from a mock, is both sides interact with the contract test. So for the consumer, the contract test acts as a really handy mock. So it saves us time because we don't have to be trying to write mocks. For the provider, the contract test acts as a really handy functional test. And it's a deeper test than just something like a Swagger validation for the syntax. It will actually be checking the semantics as well. If I pass Bob in on this interface, I expect to get Fred back. So it means that it saves the providing team time writing functional tests. And the good thing is that, if everything works, our tests pass, they're cheap and light to run. Their tests pass, they're cheap and light to run, and then things work. If something goes wrong, in this case, their implementation has gone pear-shaped. So our tests are still going to pass, but we get an alert, or rather they get an alert of the problem because their tests are failing. And that's good because if we'd actually deployed things like this, it would have failed. Similarly, if we make a change to how we call things, we get an alert really early on that, hey buddy, the interface doesn't look like that, you need to change something. So there's a few different contract testing systems out there. Spring Contract is one which works really well if you're in the Spring ecosystem. If you're a bit more polyglot, then I really like Pact. It's got bindings for almost every language that you might be using. And so it's a great thing to get in. But of course, even if we sort that out, even if at our business logic microservice layer, we're pretty safe and we're pretty decoupled, there's probably quite a lot of other things in our system that we maybe haven't thought about when we made our really clean microservices architecture. So sometimes I think, we sort of get really excited about the business logic and we forget the front and the back and then all the glue. And this is, of course, especially likely in an enterprise kind of system. So one of our architects calls this the enterprise hairball, which I really like because it just makes me think of cats. And, we all know a hairball, it's not good and you need to deal with it. So what happens is we start out and we have a monolithic business layer. And we say, I can do better than this. I'm going to get the dream of decoupling. I'm going to divide it up. And everything's working quite well. But we forgot the front end layer. So there's that. And then, of course, there's the database layer. And most often, those are still pretty monolithic. And then, of course, particularly in an enterprise context, we're going to have an integration layer. So we're going to have messaging or something like that that's pulling this quite complex system together. And this is where we start to see problems. So what most people have worked out is that every change to our business logic is going to need a change to the front end as well. So I think we're getting much better than we used to do at doing modular micro front ends. So that's kind of getting there. But of course as well, that the integration layer often is still really monolithic. And the integration team will usually be having demands on them from all sides. And I heard a colleague and they described the integration team as a panicked sandwich. And so they're sort of, they're squeezed between all these things and they have so many demands on their time and they have this monolithic thing so that they have to really schedule their changes really carefully, which blocks everybody else. And of course, it's well known we see the same thing in the database as well. So every time we want to make a change, we need to make a change to the database if we kept our database monolithic. And this can cause a lot of frustration, particularly for the integration team. They can seem really unresponsive and slow, even though they're working really hard. So we need to be sorting out the coupling at those layers as well. So we really need to be slicing the integration layer, going to a more modular integration. There's really good patterns out there for that now. Going to a more modular database where we have these vertical silos rather than having horizontal silos, because otherwise our microservices just aren't going to achieve what we want. And the main thing that we won't be achieving is we will not be achieving continuous deployment. It will be impossible because we have so many dependencies elsewhere in the hairball. So how many of you recognize this? That you work really hard, you've created something amazing, and then its value, which is just sitting on the shelf. It can't be released even though you have a microservices architecture because there's a release board. And then all the other microservices need to be released at the same time, even though independent deployability was the whole point of microservices. And then there's a release checklist. And then there's various other things that, because we're so scared of releasing, and the business is really scared of releasing because it's been burnt in the past. And so then there's this release checklist, and then there's sort of, incantations. And then, there was a deadline, and so then we still are doing this death march, even though we should be doing continuous deployment. And then we have to sacrifice a goat because we've been burnt in the past when we didn't sacrifice a goat. And then someone somewhere is tracking a spreadsheet with all the dependencies. And of course, the moon has to be in the right phase. And this wasn't what we signed up with for when we did microservices. And we see these sort of drag that prevent the releases. Sometimes that actually gets enforced at a technical level as well as at a process level. So what we sometimes see is we see pipelines that have been carefully crafted so that every microservice has to go through the same release pipeline to enforce that we don't have independent deployability. That wasn't the point. That wasn't why we were trying to do this. And usually the reason that we're so scared of releasing, the reason why releasing is this sort of horrifying prospect is because there's a ton of manual work around it. And in particular, the tests aren't automated. And when I visit a client and I hear our tests aren't automated, what I actually hear is we have no idea if our code works at the moment. It might work, It worked last time we did manual QA. We hope it still works. But really, you've got to have that automation of quality. Especially if you're going to be, the sort of the spaghetti architecture, which is frankly quite hard to resolve. It's easy to say don't be spaghetti. It's hard in practice. But if you're going to be spaghetti, you've at least got to be tested spaghetti so that you have that confidence. And then we see as well that even if there's automated tests to do the actual release, there's a whole bunch of extra stuff which is manual. And then if we have concerns about compliance, there's a whole bunch of manual compliance work. And of course, if especially if we're in a regulated industry, if we care about compliance, well, anything we care about, we should automate it. And then, of course, we see that even once we actually get it out the door, to try and figure out if things are going wrong tends to be a fairly manual process as well. So with all these manual processes and with all these slowdowns, what that really means is that even though we're deploying to the cloud, we're not getting the promise of the cloud. We're sort of using the cloud as though it isn't a cloud. And fundamentally with the cloud, things that we used to do, that used to be a good idea, that used to keep us safer, are actually hurting us. So old style governance in the cloud doesn't work. It doesn't achieve the business outcomes that we were hoping for, and it loses a lot of the business benefits of the cloud. A colleague of mine spoke to a large bank, and they were sort of this was in East Asia, and they were a legacy bank, and their lunch was getting eaten by all of the fintechs and all of these upstart banks. And they could see that they just couldn't move quickly enough to keep up. And that was partly why they were really losing. And so they came to us and they said, we're going too slowly. We've got this big COBOL estate. We think that's what's slowing us down. And that was quite possibly true. We need to get rid of this COBOL. We need to make microservices because everybody else is doing microservices. And we said, yep, great, yep, we can help you with this. And then they added, but our release board only meets twice a year. So if your release board only meets every 6 months, your release cadence is going to be every 6 months. So it doesn't matter how many independently deployable microservices you have, you're not going to get the agility. So at that point we thought, well, yeah, we can help you, but the help you need isn't technical help. We need to sort out this first. We need to sort out the automation. We need to sort out some of that continuous delivery, because that is what's holding you back, not the COBOL, even though the COBOL sort of is sat there looking antique. And I think, we say, oh, I want to be decomposed, but decomposed has more than one meaning. And when we want for a decomposed application, that doesn't guarantee modularity. Sometimes it just means that the mess is spread more widely. And if there's these other external constraints that are what's holding us back, until we fix those, it doesn't matter how decomposed we are. So I'm really looking forward to your questions. Thanks very much.
That was a great talk. And it sort of mirrors some of the experiences I've had with working with clients as well. I mean, it really did. I kind of want to talk about the testing side of it. Like, I mean, how sort of widespread do you think automated testing is? And then we can get to contract testing in particular after that.
Yeah, so even automated testing, it's one of those things, everybody loves the idea, and then you go to do it and it's really expensive. And if you're trying to move with a lot of speed, then sometimes that ends up being the thing that falls by the wayside. Or sometimes if we're changing really fast, then we know that every time we change something, we have to rewrite all our automated tests. So we say, okay, no, we'll just do it manually. And manual testing has its place. But I think we all have good intentions and slightly less good execution with automated testing. Unless you do TDD, of course, which you should do. But that's a
Yeah,
different conversation.
because I've certainly seen with organizations, it's like, yeah, the developers write a few tests and then we just give it to QA to do whatever they do, and which is sort of kind of not in the spirit of microservices. Um, then, yeah, I mean, what about like consumer-driven contract testing?
Yeah, those I think aren't very widely adopted, which I sort of, this is sort of, if I had all the time in the world, I'd just go around and talk about consumer-driven contract tests and then talk to people who, to see why they're not doing it. Because I sort of, it seems so natural to me that this is a problem that we all have, you know, and we're all trying to solve this problem in lots of different ways, like making our pipeline release everything at the same time, or having, you know, the goat sacrificing in the 2-week QA phase. And, you know, the correct solution to this problem is contract tests, but there's good reasons not to do contract tests as well, or there's barriers to them. So we had some conversation in the chat. I mean, there's such great conversation in the chat, but one of the questions was, well, as a producer, is it my fault if I break you as a consumer? And different teams are going to have different answers to that question. And the way a contract test will work is that usually the consuming team will check their tests or their contracts into the producer's build. And then that means that if they change something, the producer's build can break. And often producing teams will be like, well, wait a minute, no, it is not my fault that this build broke. You just did something and I was doing everything perfectly right. So then the question is, well, if we can't have a good negotiation and a good conversation about what our API should be at the build level and at the test level, are we really confident that we can have a grown-up conversation about our API and whose fault it is that something breaks when it's actually out in the field? So there's sort of, I think it's really hard to get right, but I think that should be a red flag, that if you can't do the negotiation about the contract testing, then and figure out whose fault it is at the contract testing level, you're definitely not going to be able to do it at the runtime level. But the other problem with contract testing is it's just really hard. and this, I think, seems like a solvable problem. But often when I'm working with teams and I'm explaining contract testing, when you actually sort of get down to it sort of, we end up doing things like testing the mock because we really care what the other side does, and we have this mock that's coming in, so we sort of do a lot of testing of the mock, and you know, then we have to sort of step back and say, oh, wait a minute, I just spent 2 hours testing a mock that I defined. let me stop doing that.
Yeah, and then maybe it also plays into the fact that organizations are used to end-to-end testing of the entire system, so it feels more comfortable to do that rather than true independent deployment of microservices, which requires contract testing. I think.
Yeah, I think contracts. Oh, sorry. I think contract tests are almost the worst of both worlds because they don't give you that sort of snuggly confidence that you would get from doing end-to-end testing because it's in all these little bits. But at the same time, it really exposes that there's coupling. You know, so my tests can break you. And we sort of have this idea with microservices that we're completely decoupled and we can do whatever we want, and any code change I make doesn't affect anybody else. But of course, that's not how it works. So it kind of exposes that gritty, icky truth that we were kind of hoping to ignore.
Yeah, but you know, I often like to use the analogy that, like, imagine you're responsible for a plane. You know, you change the light bulb over someone's seat. Just say part of it's broken. You don't need to take the whole thing for a test flight just to verify that fix works, right?
Yeah, if you look at the PACT website, they have this great analogy that I sometimes use, which is about fire alarm testing. So, like, you know, because we all have, you know, our fire alarms, and there's a little button on it that you push and it says test, and that tells you it makes a noise, but it doesn't necessarily give you any confidence that you haven't like painted over all the things that let the smoke in, and that actually, if your house was on fire, it would make a noise. It just tells you if I push the button, it makes a noise, and that's like, you know, a unit test. And then at the sort of the other end, you have the integration test of, I put some matches to my house and it goes up in flames, and from through the inferno, I can hear beep, beep, beep. And I have a lot of confidence, but that was a really expensive test to do. And I hope someone does it once, but I'm not going to do it every time. I want to get a bit of confidence. And so then what they have is sometimes like in institutional buildings, you can see them, it's sort of like this long stick and it's got sort of a cup on the end, and they put the cup around the fire alarm, and then it just sort of, hisses in a little bit of smoke so that you can see, okay, actually smoke causes a beep rather than button causes a beep. But I was able to learn that without burning my house down.
Yeah, that sounds like chaos engineering, isn't it? Right? Indirectly injecting faults into your production environment.
Yeah, or I think, chaos testing might be sort of, letting children with matches into the mall and making sure that you've got the fire brigade quite close by as well.
Yeah. So someone said, I want to move on from contract testing, but there was a question about should API versioning be like an alternative to contract testing?
I think API versioning is definitely a great thing. It's also really hard. But yeah, in an ideal world, you would do both. And most of the contract testing providers, they've got some quite nice versioning support as well. So then you can have a contract for each version, and you can say, okay, well, I know my provider has now moved up and they've got version 5, but I don't want to work against version 5 because that's too scary. I'm still going to be against version 4. And so then you have the best of both worlds, that they can move forward without breaking you, but you still have the confidence that you're okay. Sorry, you said you were changing the subject from contract testing.
I wanted to finish that. It was just that question just popped up in the chat. So kind of, I think going back to the beginning of your talk, and it was kind of like to get, what factors should an organization consider when thinking about microservices, or you could take a step back and choosing an architecture for their application in a monolith versus microservices. What criteria?
Yeah, so the first thing is to have that really hard conversation about why are we doing this? What problem are we really trying to solve? And is it just that we're feeling a bit left out because we can see all the cool kids are doing microservices? And then, if we sort of go off that, if we sort of resolve that, then hopefully we come up with an answer, something like we need more business agility, and we're really willing to do, the sort of the releasing and that kind of thing as well. But then you sort of want to look at things like, what size team am I? If there's only 4 people in this team, you don't need to be decoupled because there's only 4 of you. So, probably microservices would be an overhead that you don't need. If you don't really ever imagine that you're going to be releasing these things independently either, because your organization's appetite for releases is that you release every 6 months, then it's probably not a good fit. And I think as well, I've just lost my train of thought, actually. You tell me.
Yeah. I sort of, at some level, I just think, if you need to move fast, that's sort of big motivation. And your application is complex, or there's a lot of people working on it. I think it's sort of that's kind of the sweet spot, right?
Yeah. I've just remembered. I've just remembered one of the other sort of things to think about is sort of going back to that example I gave where the domain model just like really didn't split nicely. And at that point, you might say, you know what? Even though I can see that I'm kind of big enough, until I managed to, I've just spent all, a day arguing in an architecture workshop about the divisions in my domain model, and we still have all this stuff that's just spread across every microservice. At this point, the pain of this is going to be too much. So maybe let's not do it until we have a crisper set of domain boundaries.
Yeah. Oh, that sort of makes sense. I think you do have to have a good understanding of the domain and their boundaries, right? Which sort of kind of pushes you in the monolith first approach and then split later.
Yeah, because they can change as well, of course. It may be that you had this really neat boundary and then half of your data leaked across to the neighboring domain. And so then you should maybe be slicing at a different point.
Yeah. Trying to what else would be a good question? I mean, there was a question. Not sure if you answered this in the chat, and it's like, well, what do you do about entities that are pervasive throughout the application? Like, you could say user, right? I mean, that's
Hmm.
everywhere. Or in e-commerce, it's all about products and orders and customers. Or banks, it's accounts and customers, right? So it kind of sounds like you should only ever have three services.
Yeah, and someone did ask about this, and this is one that I still sometimes struggle with, and I always feel like a bit of a failure, and I always wish I knew a much better answer for this one, but I think it is hard. So I think one thing that you can do is you can try and say, well, I'm calling all of these product, but actually I'm using them in such different ways that they're not really products. They're not really the same thing. There's maybe like a foreign key between them, but that's the extent of the relationship. That there's one field that's the ID that's the same, but the way I use them is so different that I could actually call these things, either give them a different name or just know, okay, I've got my warehousing product, and then I've got my banking product, and they're different. The other thing that you can do is you could sort of do the upfront work and say, okay, we're going to accept that these are really pervasive, and so they do not change, because we know if they change, that will be a world of pain. But then you just have to make that really explicit and say, okay, we're confident enough in these that we're willing to accept the coupling on these. The other thing you can do as well is you can have a little translation layer. So you can say, well, we thought they were going to be the same, but actually they've changed over here. In order to allow that microservice to continue to evolve, we'll just put a little buffer between it.
Yeah. Yeah. Well, I feel like we could talk about this for a while, but it looks like we're out of time. But maybe, in the panel discussion that follows the talks, we could follow up on some of these issues, as well as I think there's some hallway chat right after this, right?
Yeah. There's
Or,
a Zoom hallway track, so I'll be heading over to that.
cool. All right. Well, thank you so much for your presentation. It was good to talk.
Yeah, my pleasure. Thank you for inviting me.